Spirit. This is Xavier Adapa, Jonathan Henley, Kirk Krause, J.C. Myers, and Jordan Sakakini, and we are the Baylor Consulting Team for Robotics, a company interested in improving robotic awareness, because an ever-increasing robot market needs better awareness. To better understand why robots need better awareness, a good place to start is with an understanding of the current state of robotics technology. What this slide illustrates here are the different types of robots that exist today, the two main categories being stationary and mobile systems. With the stationary systems, you have the single-unit robots that work individually to complete a single task. And you also have the multiple-unit robots that work together to complete either the same or different tasks. These robots are commonly found in manufacturing and warehouses where you typically see assembly lines. With the other category of robots, you have your mobile systems, such as the single-unit system that is designed to complete a single task by itself, such as iRobot's Roomba. You have multiple unit systems that are also designed to complete the same task, but while there may be multiple versions of the same robot working in the same space to complete the same task, they do so individually and do not work together to complete that task. An example would be the Kiva robots that are used by Amazon in their warehouses. And finally, the last group of robots are the swarm unit robots, which, like the multiple unit robots, are designed to complete the same task. However, they can communicate with each other to work together to complete that task. Now, all these robots, all of them currently are available commercially today, except for the swarm unit robots, which are only currently being used in research. With all these robots, a general characteristic that they tend to lack is a sense of awareness of both each other as well as their environment. As illustrated in this video here, these two robots are unaware of each other, and thus they collide. Now, these robots are small and moving relatively slowly, so they do not cause a lot of damage. But imagine if they were larger and moving faster, such as two robotically driven tractors that are worth several hundreds of thousands of dollars. If they were to collide, they could cause a lot more damage to both themselves as well as their environment, which could be rather costly. The other form of lack of awareness that exists is a lack of awareness of their environment. Now, with this robot here, it is unaware of the boundary of its environment, and thus it collides with that boundary, falls over, and causes damage to itself. Now, if this robot were to be in the vicinity of other property, and maybe even people, the consequences of that lack of awareness could be more severe. Part of the reason why this lack of awareness occurs is because these robots are unable to communicate and share data with one another. What this figure illustrates here are the current robots that can actually communicate. On the bottom, you have the two types of stationary robots, and they're able to communicate with each other through the use of custom systems integration. However, that type of integration is only currently available for stationary systems and is not yet a viable option for mobile systems. The other group of robots that can communicate with one another are the swarm robots. But they are able to communicate with one another because they are made by the same manufacturer and because they are working to complete the same task. As for the single unit systems and the multiple unit systems that are from the same and different manufacturers, they are unable to communicate with anyone. And so what this illustrates is that in general, these robots that are from different manufacturers and even the same manufacturer are never unable to communicate and thus are unable to maintain or elevate each other's capabilities when performing separate or cooperative tasks. Thus, these robots cannot maintain their efficiency. Now, to address this problem, I'm going to pass it off to Jordan Sakakini to discuss our proposed solutions.
Thank you, Grace. So as Grace mentioned, one of the main problems in robotics today is situational awareness. Our proposed solution to this is a middleware product that will be able to plug into robots and provide a social mapping. So as you can see in this video here, the black and blue robots are moving about, and they can map the local area around them, but they're also aware of everything that's going on. So this map that we're proposing needs to have a preset map. It needs to have, say, for this example, the blueprint, the walls, all the furniture, the stuff that's not going to move. But it also needs to have adaptive mapping. It needs to map its local area in real time and be able to share that information with a cloud-based server that can compile all of the local robots. So say in a hospital wing, it would combine information on the local mapping from all the robots in that hospital wing and collect it together. This middleware product also needs to be able to plug in, so by USB or FireWire or some other connection port. And finally, since we are using a cloud-based server, we'll need to take into account network security. Now, a little bit about how this map works. We'll have a base preset map that will be preloaded into an area, and this will feed into an adaptive map. This adaptive map, which will be located on the middleware that's plugged into the robot, will receive data from the sensor module, such as position and velocity, overlay that onto the adaptive map, and then send that to the compile map, which is on the cloud-based server. This compile map will take in information from all of the different robots in the specific area and send it back to the adaptive map so that the adaptive map can update. Then this will be sent out to the control module on the individual robots so that they can efficiently and effectively get to their destination. Then the next time step occurs and the whole process repeats. Now, unfortunately, many of these technologies do not yet exist, so we're proposing that our company begin its life as a systems integration company that is focused on fixed and mobile systems. This will allow us to not only get our foot in the door in the market, but also generate experience. We know this can be potentially successful because, as you can see on this graph, there are several industries in which they actually spend more money on integration of their robots than the robots themselves. Industries such as transportation and professional service spend more money integrating the robots they have than just buying the robots. Next, Kurt will talk a little bit about the markets we hope to attack.
Thank you, Jordan. All right, as you can see with this graph right here, this is our general market that we're going to be attacking. It is the robot market, and it's rapidly expanding. As you can see here, in 2025, it is slated to be a $67 billion industry. And with this, we'll be able to insert ourselves today and take advantage of this great opportunity. Here you can see that this is the key international markets. So by country that have the most robots today and who are growing into the future. It goes Germany, South Korea, Japan, North America, and then China. China being the one that's growing the most out of them, but everyone else is growing as well. Here is the customers today. We're looking at defense, field, logistics, and the medical industries. And number one is defense, but we are not going to target them mostly because there's a high probability that the contracts are going to be hard to get. And also, if we were to try to sell to other industries like field or logistics, we would have to wait till the technology is declassified to do so. So that leaves us with field. Field is agricultural robots, as you can see with the pictures, and through our research, we found that any technology that agricultural people, farmers, would be able to use to better make their crops work better for them, they'd be definitely interested in that. And this is customers tomorrow, and as you can see here, home, which is individual consumers, is going to be on the rise closer to the future, so closer to 2025. And with this, I'm going to be passing this over to Xavier Dapa to talk about the competition.
Thank you, Kurt. So I'll be talking about how our company stacks up relative to competition, how we offer a uniquely advantaged solution. So firstly, some criteria that we are going to look at are our integration capabilities as well as our social mapping capabilities of our product, along with the plug-in adaptability to be used with any robotic system and the availability of that product. So starting with our closest competition, our closest competitor is Synapticon. And they're a Germany-based company who specializes in developing hardware and software for companies. They do integration as well, and they also do custom designing for whatever software or hardware specifications you send them. As you can see, they match up pretty well against us in most categories. However, on the social mapping aspect, they do not pose a threat because of the lack of understanding of how to do so. Next, we're going to look at systems integration companies. One product would be Robotic System Integrations, who specializes, obviously, in integrating industrial robots. However, they do not specialize in integrating mobile robotic systems and do not have the capability of shared mapping or plug-in adaptability. Next, we're going to look at cloud services. Cloud services are integratable to any robot that uses internet or provide shared mapping capabilities or social mapping capabilities, but however are plug-in adaptable and available readily soon. And finally, we're going to look at robot manufacturers such as iRobot. Robot manufacturers are just that, manufacturers. They do not integrate, they do not provide any services in terms of mapping or plugin adaptability, but obviously are available very soon. One example would be Roomba. So next, I'm going to talk about our alliances and possibly a licensed technology that we could use within our product. So when you're talking about social mapping, you want something that's real-time, therefore high speed. So latency is a term that describes a high-speed connection or the speed of a connection. So when you're doing, like I said, with social mapping, high-speed connectivity is pertinent when you want accuracy in real time. So we looked at a couple models of business to provide that high-speed connection. So we looked at Netflix. They have a unique model. What they do is that they go to local ISPs and they provide dedicated servers in which they upload content during downtime between 2 a.m. and 2 p.m. And they update their servers, and those servers provide wireless connectivity to the servers that the ISPs have, the caches that the ISPs have, and they upload content onto your machine. Secondly, Profit Bricks, which is perhaps a cheaper solution, is a young and upcoming wireless IaaS, which is infrastructure as a service. They provide a cloud service specializing in high infrastructure and high power connection. And we think this would be a good solution because it would be a good mutual alliance to have because they would be cheap and they're a relatively new startup. So moving on to some licensed technology, NVIDIA is a company that specializes in developing graphics processor units, and we chose to use NVIDIA as a proxy mostly because they are on the cutting edge of graphic processing unit development, as well as our product is going to need something like GPU to handle the shared mapping capabilities, because GPUs are really good at handling parallel processing, which is just another way of saying they're good at processing large amounts of data simultaneously and very quickly. So next, I'm going to hand it over to JC Myers to talk about the strategic and legal constraints of our product.
Thanks, with our product, we're going to be introducing a lot of new technology into the market. With that, we're going to continue to protect our intellectual property. Our company, Robotics, we're going to need to trademark our name. That provides brand recognition and perhaps licensing opportunities later in our company's life. We're going to need to copyright all of our software. We're going to have advanced mapping, communication, and translation software that we're going to need to copyright in order to protect our intellectual property. Finally, we're going to need to patent our hardware and our architecture. The hardware being the actual middleware plugin that that is what we're going to be selling, the actual device we sell. And finally, the architecture that we're going to patent is going to be the plugin processes and any necessary components required to make the product work. We're also going to need to take into account the other companies in this marketplace, their copyrights and their patents as well, so that we do not infringe on their intellectual property. We do not want to be sued this early in our company's life. Next, we have legal constraints. Damage liability. When robots and our technology become more prominent in the marketplace, accidents can occur. As you saw in the video earlier, when small robots run into each other, probably not a big problem. If large robots run into each other, lots of damage, lots of costs, and lots of potential injuries. We're going to need to have a very detailed term.
Any of these services. And what will the cost be for this systems integrations company and also the product company? It's $3 million total that we're asking for the beginning of the product launch and also the company launch. $1 million of this will go to the systems integrations company for hiring the necessary specialists and engineers in the field. And this company will be able to inject the revenue generated back into the company. As you can see in the table, it is roughly a 20% earnings that come from revenue that will be able to be discretionary owner earnings that can be injected back into the company. As we have talked about before, this is a market that is ever expanding, so this is something that can be very exciting as robots continue to be more prevalent in our society. The next part of our company will happen later on in the first year of the company's development, and it will be $2 million, and this data is validated by Synapticon, which is a company who is providing a product that will be similar to ours. And the first $1 million will go to the employees that will be product engineers who will develop this, and the second $1 million will go to R&D, things that will be necessary to establish this product and create it and keep it going. And over the next 4 years, we will be able to decrease costs since we will be having more revenue increase, and also the technology that we have will not need to be purchased again, and it will be a more viable option. And now Grace will and now we will go to the business timeline. As you can see, there will be 3 phases that we will go through. The first phase is conflict avoidance. With this phase, we will focus on primarily our product, and it will be within the first 18 months. Within the first year, we will have our mapping product that is necessary, and we will have angel funding, and then also the initial targeted alpha customers within the first 18 months. As you can see, our company will be an integration company throughout the life of it, and it will also focus on research and development that will be necessary to keep our product on the leading edge. And the next phase will be coordination, and that will be phase 2, and this will occur up until year 4. At year 4, we will be able to have a product that is coordinated and will continue with development until we get to the final phase, which is phase 3, and that will be till the end of our life of a company. And that will be a group problem-solving solution that will have cloud services and also be able to allow the robots to coordinate efficiently. And now Grace will summarize the rest of our presentation.
Thank you, John. So in summary, here are the main points of our presentation. The problem that we are seeking to address is that current robotic technology needs better awareness. Our company, Robotics, will offer systems integration service and various products, initially our mapping product, to address this problem. With our services and our products, we will be targeting the robotics market as well as key international markets, and this has potential for success because all of these markets are currently expanding. Within these markets, there are customers that exist today, especially in agriculture, which we have confirmed through primary research with companies such as Robotics, which makes agriculture drones, showing interest in our product. With our product and our services, they will be competitive because they offer better solutions over our competitors because they will fill the gaps that are left by our competitors. We also recognize that there are several key technological and strategic issues that will need to be addressed, and we will address them proactively. And then finally, both parts of our company, both the systems integration services and the product development, will work together to produce the product, offer the integration, and ultimately maximize profit. And that concludes our presentation. Are there any questions?
So you mentioned that it's a $67 billion global market.
By 2024.
Right, but you're focusing on the agricultural piece of that. Do you know how much that is of that total?
Not specifically, but we do know that they do have a lot of revenue, and in fact that they're from doing secondary research that they are increasing their total revenue yearly by approximately 15 to 20% per year. So they are a growing market that can be targeted.
You also show China as one of the leaders in that growth. Is that growth in China driven by what you call field-based solutions?
Part of it, with
Yes.
the majority of being with industrial robots at the moment, but they are open to agricultural technologies as well. Yes.
My suggestion is that's something that you look at is what is your real total available market given the current status of the product development and where you're going short, medium, and long term.
What do you, I'm an Aggie, so I gotta use small words and short sentences. So for agricultural, what exactly, you know, right now they're using GPS systems for crop optimization and planning, et cetera. So what exactly are you going to do?
So one of the main problems with the GPS operated systems is that if they have a GPS operated tractor at the edges of the field, there's trees and stuff, so the GPS signals are lost, and they still have to have a person inside the tractor to make those turns. So we've been thinking about potentially having a system where they have overhead drones that provide both crop health, they can monitor crop health, but also help to provide information about location for those tractors.
Yes, there's also a company called Robotics, and they specialize in developing surveillance drones as well as quadcopters that use cloud-based systems and cloud-based network, and they also use NIR. So the NIR hovers above the field, and it surveys the land using a sort of temperature. It gives information on how the conditions of the plants and the crops are.
What is it robotics is actually supplying? It's mainly the software integration and not really the equipment, the robotic equipment, or just drones, or tell me again.
So what we are
your supply.
providing is a middleware solution that will be easily adaptable into the robot's post-production. So something that, for instance, could plug into a USB port on the robot. And this would provide a better mapping solution for these robots that can be continually updated with new information from the robot, such as where the robots are located, as well as any new obstacles that may be around them. And this would allow robots that share this network to know where the obstacles are located so that they can anticipate if they need to change their trajectory in order to maintain their efficiency.
And that's easily integratable with existing equipment?
It depends on the robot. Some robots are standardized with either USB or FireWire. So as standardization continues with the robots, that interface may become more standardized, and so then we can limit our middleware to just that interface. However, right now, what we would suggest would be that potentially with this middleware product, initially offering several different types of interfaces.
Would the manufacturers in advance kind of have to conform to that interface standard in order for it to be used?
Yes, it's going to probably be the IEEE standard, and they're already aware of this. It's the standard body of that. So once that happens, we'll in turn have our product fit that standard, and it'll work seamlessly.
So the standard hasn't been developed yet, but it's
It's undergoing a similar process as computers did. So in the beginning, computers had a lot of different interfaces, but they're working towards a standardization. So you're seeing that happen with robots as well.
It sounds like you may need like a consulting arm within your business to consult with clients to help integrate. To me, I think initially, before all this, uniformity of technology is established,
And part of that will also be achieved through starting out as a systems integration company, because we'll be working with fixed and mobile systems. So while we're working to integrate those systems, we will also get experience with those systems to see what is the most prevalent type of interface or most prevalent type of software being used on those robots, so that we can develop our product to fit the majority of them.
I had one last question. Nowhere did you mention the cost of your product or service compared to the competition. How does that stack up?
I can answer that. So there's only one company out there right now, and that's why this is such an exciting thing, is that it isn't very, it's a blue ocean, as we've mentioned before. Synapticon is the only competitor that we can really base our financials off of. And they recently, in data that we've obtained through Privco, had angel funding and also VC funding that was $2 million. And we projected that as the product development. And we looked at the $1 million would go straight for the systems integrations company. As Grace mentioned, we would be able to use that as free R&D also for our product.
But how does the cost compare to their solution?
This final product you're selling to the customer, how does that stack up? I guess that's what I was asking.
Product engineers become involved, determining what exactly is going to go into the product and how much of it they're going to use.
It's too early.
Yeah, it's too early.
Too early to tell.
You talked about some issues around damage liability and integration with the cloud. If you're doing a snap-in solution, do you really carry that liability, or does the company for which you're doing the integration?
Most likely, the company that we're doing the integration would have the liability, but it is something we need to be aware of and able to address, because it's potential someone may try to go after our company as being the responsible party.
Okay, so it's something in the back of your mind, but it's not a living factor.
If it is our technology that causes the mistake, if it is our map that causes two robots to collide, then that would be a potential liability.
The Netflix, help me understand the Netflix model. I'm not sure how that plays in either.
So yeah, we were looking into ways to provide high-speed connection, and so we were looking at some companies that specialize in that, and Netflix being one of them. So we looked at their model, and we learned that they provide their own dedicated service to local ISPs, both big and small, and they have a cache. The ISPs have a cache, and Netflix has a server. So Netflix updates their server, and during trough hours, they upload the cache and the.
So how do you apply that learning to your model? How would your model work?
I would say
You're not going to use Netflix, I'm assuming, to
No.
host your
right.
What it shows is that we could also take the same route of partnering directly through internet internet service providers to have dedicated lines that mean that our signals can be broadcast a lot more quickly, which is needed in order to keep latency down.
You don't expect the data to be of high volume though, right? I mean, this is pretty small packets.
It depends on how many robots are on the server, and then eventually, if these robots are moving outside of a dedicated space, like a home, and is connected to some other connection, maybe a satellite, that could be potentially a lot more information that needs to be processed a lot faster.
I would think in the agricultural industry, you're gonna be in a lot of remote rural areas where there is no connectivity. That's gonna be you have to use satellite, obviously.
No, well, Robotics is a company that uses cloud-based service to provide connection for the robots.
Anywhere.
Anywhere, yes.
And another solution is, we talk about including a server is, for instance, iRobot, they have a lawn mowing robot, and part of their signals can be bounced off of stakes that they put in the ground. And so those stakes could potentially be server towers that help to broadcast remotely to these agricultural robots so that they can have access to the map of their area.
I have a question about, you mentioned about patents, that you could patent. Is that in process right now, or is that just this is what could happen in the future? And is there a timeline on when you're going to get those patents, or if you have the technology, is that stuff ready to patent, or is that something?
That will have to be done after we figure out what's going to go into our product itself. So similar to the cost of the product, we won't be able to figure that out until we actually have our product. So the patent will have to come after.
And the $3 million that you're asking for, does that include cost of patent? In other words, so let's say I'm an investor and I've got $3 million burning a hole in my pocket and I want to put it in your company. What's my exit strategy? What am I covering? How are you going to spend it? And then how do I get out?
We didn't go into this looking for an exit strategy. Our client wants to see where this company could go because the robot market is growing. But addressing that concern, we as I said before, use Synapticon as a similar model to ours. So we are assuming that they had a legal team that was able to counsel on this. We don't have exact data, but this was just data that was taken from Crypto about the amount of money that they had initially invested.
Okay, so you're not giving what I thought about that strategy. So this is the meta strategy, this is the product that I needed. So that's set for the market. Thank you.
All right, guys.